The chip arrived in a retail box, performed on benchmark tables, and the document that confirms this is also read with care, the document that refuses to say how many more can exist. What the TechInsights teardown and die analysis of the Huawei Kirin 9000S establishes in technical photographs and layer counts and physical measurement is that an advanced domestic chip exists. What it declines to establish, by the honest boundary of its own methodology, is whether that chip can exist at scale, at yield, at cost. We will read this report twice, the first time for what it records, the second time for what it leaves blank, because the distance between those two readings is the argument. First reading, the silicon on the table. Second reading, the silence around the factory floor. The report identifies the Kirin 9000s as fabricated on a process node consistent with Semiconductor Manufacturing International's second-generation advanced node, a finding derived from physical measurement of transistor pitch and metal layer spacing. That characterization is credible and has not been seriously contested. But the phrasing the document uses, consistent with, is doing significant work. The report does not name a node by any internal foundry designation, and it does not cite a process design kit or a foundry disclosure. It reads a physical artifact and draws an inference. The careful language is itself a data point. Even the analysts writing the report understand that the physical object and the manufacturing claim are not identical things. The document records what it can reach, and it says so in its own hedged phrasing. What the teardown establishes beyond inference is this: the Kirin 9000S is a real chip, physically present, with die characteristics that place it at the advanced end of domestic Chinese production as of 2023. It carries a central processing cluster, a graphics processor, a neural processing unit, and an integrated 5G modem on a single die. It is a full-featured application processor, not a stripped-down variant. The packaging is complete and functional. The device in which it was found performed at a level that surprised a number of analysts who had publicly estimated domestic Chinese fabrication was further from this point than the artifact proved it to be. The report establishes all of this with the confidence appropriate to physical measurement. The chip exists, it is what it appears to be, and its architecture is coherent. The packaging documentation is the second close reading the report invites. The teardown records that the Kirin 9000S uses a domestic packaging approach rather than advanced heterogeneous integration of the kind found in contemporaneous NVIDIA or Apple Silicon of that period. The document does not say whether this packaging approach was selected for strategic reasons or imposed by the absence of advanced packaging capacity at the time the design was committed. That silence matters. The report describes what is on the table. It cannot say what was not on the table when the engineering choices were made. The omission is not evasion by the authors. It is the honest limit of what teardown methodology can establish, and the report makes no claim beyond that limit. Component identification in the teardown lists memory and radio frequency components, some of which carry vendor markings that analysts have associated with domestic Chinese suppliers, while others are identified only generically or not at all. The partial identification is the finding. Where the report can name a supplier, it does. Where it cannot, and the record shows several components in that category, it says so, or it stays silent. A reader who treats the unnamed components as domestic by implication is reading something the report does not say. The document names what the physical artifact reveals. It has no method for resolving what the artifact conceals. Now the second reading begins, and it begins with yield. The teardown report says nothing about yield, the fraction of dies on a wafer that function correctly. It cannot say this. A teardown begins with a working chip, by definition. Every chip examined in a teardown is a survivor. Think of this report as a post-race inspection of a winning car. The inspectors can tell you exactly how the engine is built, what is in the fuel system, how the components are arranged. What they cannot tell you is how many engines were assembled before this one completed a lap. The trophy in the photograph is real. The parts bin behind the garage is not in the photograph. Yield is precisely the figure that separates a technical demonstration from a manufacturing economy, and the document is constitutionally blind to it. The report establishes that some chips came out right. It has no mechanism to establish how many did not. Production volume does not appear in the teardown report, not as a figure, not as an estimate, not even as a proxy. The report examined one chip, the broader shipment figures that have circulated, analyst estimates of units sold. Import data for the Mate 60 Pro series come from sources entirely outside this document. When the teardown is cited as evidence of Chinese manufacturing scale, the word scale has been imported from outside the record. The document does not support that import. It records a chip. It does not record a production line. Foreign tool dependence is the third omission, and it may be the most consequential. The teardown report identifies what is in the chip. It has no method for identifying what equipment produced the chip, the lithography systems, the deposition tools, the metrology hardware present on the Semiconductor Manufacturing International fab floor when this wafer was processed. The report cannot see the supply chain that produced the artifact it is reading. Whether that supply chain relies on equipment manufactured before export controls tightened, or on domestically developed alternatives, or on some combination of both, is a question the document leaves entirely open. The die is domestic. The document does not say the means of producing the die are domestic. Cost is the fourth absence. The teardown records architecture. It does not record economics. That distinction matters because the competitive frame in which this chip is most often discussed, a challenge to NVIDIA's position in artificial intelligence accelerators, or to Apple's vertical integration in premium mobile, is partly an economic frame, not only a technical one. A chip that costs several multiples of a nominal competitor to produce may be a technical peer and an economic non-starter simultaneously. The teardown report has nothing to say about this. Inciting it in an economic argument requires importing an assumption the document does not make. The limits of the document are themselves further omissions worth naming. The teardown examined a chip from a consumer device released in a specific window. It does not say whether subsequent production runs reflect identical process parameters, improved ones, or degraded ones. The document is a snapshot. The snapshot does not settle the trajectory. The report's node identification rests on physical measurement by a specific analytical firm at a specific moment. It does not foreclose a later reanalysis reaching a different characterization, and it does not carry the authority of a foundry process disclosure. The components the report could not identify are not resolved by the report's silence. The document does not confirm they are domestic, and it does not confirm they are foreign. It confirms only that physical inspection of this artifact did not settle the question. What the teardown cannot reach at all: any data on Semiconductor Manufacturing International's capacity utilization, its capital equipment inventory, or its ability to sustain this process node across a production ramp rather than a limited run. A close reading that mistakes the boundary of the document for the boundary of the truth will overstate what the teardown establishes. The record proves one chip at one moment to one level of analytical certainty, and it leaves the industrial question entirely to other documents that have not yet been read with the same care. Read the TechInsights teardown on the Kirin 9000S, and what it gives you is precise and real. A domestic Chinese chip at an advanced node, fully integrated, functional in a shipping consumer device. Read it again, and what you find is that the document is carefully bounded. It records the artifact, not the system. The output, not the rate. The architecture, not the economics. The wall that export controls wrote into policy produced a chip this report can confirm. What the report cannot confirm is whether that chip is a ceiling or a floor. The document proves the chip. It does not prove the industry. The teardown tells us what came out of the fab. The next document to read closely is the one that might tell us what went in, and whether the supply chain that produced this artifact has a ceiling of its own. What document would you bring to that reading? If you want to read the next record alongside us, subscribe and turn on notifications. The document is already on the table.